So if we could see what's going on in a chemical reaction, we would see that atoms are combining with other atoms to form new compounds, that the starting molecules are being broken apart and new things are forming. I think Legos are a good analogy, or if you were deprived as a child and had Tinker Toys or something, that works too. But some building block thing that sticks together. And so maybe you made these two little people out of Legos. And the chemical reaction is you taking the little people apart and making a big tree out of the pieces. The pieces are all still there. The pieces are unchanged. The atoms do not change in a chemical reaction, but they get rearranged. So it's important to understand at that particulate level what's going on in a chemical reaction. We're just rearranging the atoms, okay? We can't see that happening, but there are some things that we can observe, and we call this evidence for a chemical reaction, the different things that we can observe. One thing we can observe is a color change. So if we see a permanent color change, then often that indicates that some sort of a chemical reaction has occurred. Here's an illustration of a baby spoon, and it's coated in plastic that's temperature sensitive. So you put it in something that's too warm for your baby to be eating, and the spoon changes color. And that's to alert you and say, hey, stupid, don't put that in your baby's mouth, you're going to hurt them. Okay? Better cool that off now. So there's a chemical change caused by heat in the substance in that plastic. Some chemical changes are reversible, and when you cool that spoon down, the color change is going to change again back to its original color. So some reactions are reversible. These evidences are not foolproof, as we'll see in a little bit.
What happens to those when it stops working? Sometimes those spoons over time, they stop doing the change, they kind of find the middle ground.
Yeah, what happens when those spoons stop changing? I think eventually a lot of compounds will decompose. They'll perhaps undergo other reactions. I think you've probably, we had a swimming pool, and we had a little tarp that we put over it, and then, we got rid of the swimming pool, and the tarp got buried under some leaves or something in the corner of the yard. We don't do a lot of yard work at our house. And then you come and you find it a couple years later, and it's all disintegrated into now it's little pieces of blue plastic in your garden. It's lovely. So why did it do that? Well, the molecules that were composing the plastic broke down. And so when the spoon stops working, it's because the chemicals, the molecules that are doing that color change have changed in a way that we didn't want them to change.
Okay, but the spoon itself didn't change in structure.
No. The reason that it changes color is often just a very tiny difference in the structure of the molecule. And so, yes, the spoon may appear exactly the same in terms of texture and shape, and it's not going to be toxic or anything, but it's just not going to change color anymore.
Is the color designed from, once the chemical reaction takes place and it's altered because of temperature, then it absorbs a different wavelength, correct? And so that's what we're seeing as a reaction of that.
Right. Things have color because of how they absorb or reflect light. And so you can have something change color by just altering it very, very slightly, and even something like temperature can alter some things to make them reflect or absorb light in a different way. When we see a shirt that appears to be red, it's because that shirt is not absorbing red, it's reflecting red.
So like, back was it the late 80s, early 90s when they had the t-shirts that changed color?
Mm-hmm.
They were doing the same kind of thing?
Yeah, those t-shirts actually were reacting to the sunlight, and it wasn't the heat necessarily, but it was the ultraviolet light from the sun that would cause them to change. And so you got this t-shirt, my kids had some of those. You had these t-shirts that looked like they were just black outlining a picture, but then when you went out in the sun, all these colors appeared. It was very, very cool. I'm not sure why those fell out of fashion. I got tired of them, I guess. I still think they're pretty cool. But we have some cups at home that you put ice water in them, and it changes color. And that's cool because you can grab it with your hand, and where your warm fingers are, then it'll change back to the other color. And the kids just think that's really cool. Color changing all by itself is like magic, right? And then you get those Barbies and you get their hair wet and it changes color, or you get them warm and they change color. It's a chemical reaction. Okay, so formation of a solid. In this illustration, we have this clear yellow liquid being poured into a clear colorless liquid that looks like water, but it's not. And we get this rusty brown solid forming. When we mix two liquids and the solution gets cloudy, that's indication that a solid is forming. We may not see, big chunks of solid form at the bottom. They often form in little tiny particles, but those little particles do not allow light to pass through, and so then the solution appears milky or cloudy, like you can't see through it anymore. And so that tells us that a solid was formed. So formation of a solid, these are called precipitation reactions. In meteorology, and the weatherman talks about precipitation. He's talking about things that fall from the sky, right? Hail, rain, snow, things that precipitate. They just suddenly come and they fall down. And so when we mix these things, this is like, it often looks a little bit like snow. That's a bad color for snow, but it tends to fall down, and it's this stuff that wasn't there before. So it's a precipitate. Formation of a gas, we talked a little bit about that as a type of reaction. That's also evidence for a chemical change, a chemical reaction. So here's an illustration of an Alka-Seltzer tablet. You drop it in water, plop, plop, fizz, fizz. Oh, what a relief it is. You remember that commercial? So you put it in water and it starts fizzing. It's giving off a gas. That gas is a new substance that wasn't there before. It's caused by rearranging a chemical change, rearranging the atoms. And so now you've got a gas. So when you mix two things and you see fizzing or bubbling, that's going to be evidence of a chemical change. Sometimes you won't actually see bubbling, but you may smell something that you didn't smell before. You mix two solutions and all of a sudden you get this really strong whiff of ammonia. Ammonia does not smell good. They didn't smell like that before. Well, ammonia is a gas with a very strong odor, and it wasn't there before. So this new smell tells us there must be some gas that was given off by that. Absorption of heat and emission of heat or emission of light. So here is an illustration of a natural gas flame. And when we burn natural gas, we get heat off of it. That's why we burn natural gas, is to, boil water to make spaghetti or something. And we also get some light off of that. That energy being released is evidence for a chemical change. One of these instant cold packs, there are also instant hot packs. You buy those at the drugstore, and there's some little container inside that you have to break, and you mix them together, and it's like magic. It gets hot all by itself for the hot pack, or it gets cold all by itself. Wow, how does that work? Is there a little tiny freezer in there, little tiny battery? No, it's a chemical reaction. It's a chemical reaction when it gets cold, a chemical reaction that is absorbing heat energy from outside. And so when you touch it with your hands, it's sucking heat out of your hands. And it's turning that heat energy into a different form of energy that's being stored away. And that's how it gets cold. Glow sticks. Glow sticks are just really fun. My kids love glow sticks. So again, there's that little glass tube inside, and you break it, and then the two liquids mix, and all of a sudden it starts glowing. Where's this light coming from? It's a chemical reaction that causes light to be given off. Interestingly, if you've been playing with your glow sticks and now it's time to go to bed, and the glow stick's still going strong, you can stick it in the freezer. Many chemical reactions happen at a slower rate when they're colder. And so if you put the glow stick in the freezer, the reaction will slow way down, and the next evening you can pull it out, and as it warms up, it'll start glowing again. So that might be fun to try at home. Pardon me?
I said mine never did as a kid.
Really? Maybe you played with them too long and they were pretty much done by the time you put them in there. You were one of those kids that stayed up till midnight, weren't you? I have kids like that. They just keep going and going. So those are evidences of a chemical reaction, but sometimes we can be fooled by them. So here, if we think about boiling water. So here's a container of water on the stove and it's boiling. We may say, oh look, there's a gas being given off, this must be a chemical change. Well, we have to think about it though. All that's happening is a state change. We're going from a liquid to a gas. And if we look at the illustration here, these little water molecules, they're not being changed, are they? They're just getting more energy, they're moving away from each other. And so it's only a chemical change if the particles are actually changing, if those Legos are being taken apart and made into some other Lego creation. So here's an example. Which changes involve a chemical reaction? And then always the fun one, explain your answers. So one thing that I'm really big on, and this lab manual doesn't do it too much, but a lot of lab manuals, they'll ask you multiple questions in one question. They'll like this one, which change involves a chemical reaction? Explain your answer. And students tend to ignore the second part, explain, but that's actually a very important part. And it's a good lesson to learn for all of life to be able to answer things completely, okay? And usually, at least in my mind, any answer is better than no answer, even a wrong answer. Thank you for acknowledging that I asked you a question, even if your answer's wrong. Don't just ignore questions and be aware of multiple part questions. So butane burning in a butane lighter, is this a chemical change, a chemical reaction? Yes, it is. Why?
It's utilizing oxygen and heat to rearrange the molecules.
Yeah, we have evidence of light and heat being emitted as suggesting that this is a chemical reaction. We know that it's burning, it's combusting, and so the butane is reacting with oxygen in the air, and it's turning into carbon dioxide and water, and it's giving off light and heat. How about butane evaporating out of a butane lighter? Chemical reaction? Physical change. The word evaporating tells us it's just a state change. If you flick your Bic gently so that you don't actually light it, the butane is going to just evaporate out. But there's no light, there's no heat, and the butane isn't changed. Now you just have, butane molecules that are free to go away. How about wood burning? That is a chemical reaction. Why?
The fire is converting the cellulose.
Yeah, the fire is burning up the substances. We've got light and heat again being given off, so that's a clue. And if you were to explain and you said, well, it's a chemical reaction because light and heat are given off, I'd say, that's good enough explanation. Wood contains a lot of carbon and hydrogen and oxygen, and when the wood burns, it mostly goes into carbon dioxide and water. A lot of combustion reactions do that. How about dry ice subliming? Chemical reaction or not? That's a physical change. Again, that's just a state change. Dry ice is solid carbon dioxide. And solid carbon dioxide is really cool because it doesn't actually melt. It goes directly from the solid state to the gas state, and that's why it's called dry ice. Because regular ice gets wet pretty fast, doesn't it? So if you want to, pack something like they ship drugs that need to be refrigerated, they'll pack them in dry ice because they're not going to make a mess on the way. So that's also a state change.